Direct show of dynamics, determination of acting forces. Article 9.7 of the book Mechanical Systems Calculations of the Marine Facilities. The direct show dynamics is finding the forces and the moments, that is the efforts acting on the mechanical point or on the mechanical body. If we have the definition of the trajectory of the motion or the point of the body. So we have two issues, the direct show and the inverse show. Direct is finding the forces under the assignment of the trajectory of the motion and the elements of the motion, and we have inverse issue. Inverse is find the elements of the trajectory of the motion, or could be the law of the motion, the function of the motion, and the action of the assigned forces and moment, that is the efforts. So let's consider the exercise. Exercise 1 we have here in this different one article, material point M shown on the figure 971 with the mass 1 kilos, moving according to the law. Law is assigned in the vector form, about the same as the coordinate form. So, but this vector and the sum and subvectors as well. I, J, K, also unit vectors. So the Cartesian coordinate system, this right coordinate system, if we rotate x to y and x, we will have the right screw motion along the axis z. Yes, it's right. Coordinate system, and we have the assignment of the motion. The assignment is I multiplied by e power to 2 multiplied by t. T is the parameter of the time, is the constant of Euler, plus j, the second one ordered by the ordinate axis, multiply the ratio cosine 2 by t, this is argument of the cosine, divided by 2. And the minus k is order of the applicata, multiplied by t squared. So we first have to excuse me, the assignment is to find the force sections on the point M, indefinite time moment. First, we have to transform this more convenient, the description of the motion in the vector form into the coordinate form about the same, which we consider each of the summands in the vector form of the assignment of the motion. We can consider this separately. So x equal to e power to 2 by t, t time, y ordinate equal to the ratio with we watch it in the equation, cosine 2p divided by 2, and z equal minus t squared. This is coordinates of location in the Cartesian coordinate system, meters of the point. To find the forces, I mean the forces of the inertia, which are in accordance with the Lambert concept, the forces of inertia and the balance are equal to the force acting on the material point, exactly with another direction. The forces of inertia proportional to the accelerations, acceleration equal to the second derivatives of the dependencies of the coordinate on time. So second derivative, we have the component of the acceleration projection of this axis equal to 4 by multiplied by e to the power 2 by t, y second derivative, the acceleration component in projection on ordinate axis is equal minus 2 multiplied 2 came from the cosine sign. When we has the derivative of the cosine, we have two second derivative. Second from the cosine is minus sine, from minus sine minus cosine, so we have the minus 2, and 2 times we have 2 as a factor divided by 2, so we have only 2. And by the cosine 2 by 2 multiplied by t, and the second derivative of the applicata coordinate by time is minus 2. So the first time we can 2t, and next second one minus 2. Minus remains from the original formula of the motion of the point. Next, we can find the projections of the forces of the inertia according with the second law, the Newton mechanics. The force equal of the inertia mass multiplied by the acceleration. The projections of the forces are the sequence finding of the products of masses by the definite projection of the acceleration. So we can find that the forces, we have the mass equal to 1, so the force is equal to the same as acceleration formally. Okay, and next we can to find at the initial moment of time t equal to 0 the magnitudes of the forces, the total, as for the special case, spatial mean in the space, due to the Pythagorean theorem, something like that, square root of total of two squared forces, components projections on the coordinate axis. We have this project squared, square root, etc. We have 2 multiplied by square root of 6 Newton. This is magnitude of the force action of the body at initial time. Exactly, we can find the components of the force, the components normal, tangential, etc. is no big deal, because to have that we have to use the force derivative, that is the components of the velocity. Second is acceleration, the first is velocity. After that, having the component of velocity, we can find the projection of the acceleration onto the direction of velocity of the material point. This will be the tangential acceleration, just a scalar product of the acceleration by the velocity divided the magnitude of the velocity. And after that, by the, like this one, the theorem of the, next we can find the normal acceleration as the square root of the total acceleration. This total acceleration we can find as well, divided by the is total acceleration squared minus the normal acceleration got or tangential acceleration, or if we find the normal acceleration, so not big deal. So we can find all elements of the motion of the material point assigned by the in the vector form is about the same form as the coordinate form of the assignment of the motion. But we have to find only the action force at a 0 moment of time. And so next we have another exercise. We have two blocks. This blocks moves and action of the applied external force F by the surface. The surface, we have assigned the masses of blocks. The first block is 6 kilos, the second one 4 kilos. And the force applied to 25 kilos, the total mass of both parts of the block equals to 10 kilos. 6 plus 4 is 10. So we have to find it is assigned to find the force acting between these two blocks, when we apply this force to rightward to the first block M1. So having the concept of D'Alembert, that we can consider this all balance of the force acting onto this mechanical system blocks as in static about the same formally, but we have to account as well, in accordance with D'Alembert principle, the acting forces of the inertia. Force of inertia we can find as the product of the two masses by the acceleration. Besides of the forces of the inertia of these two blocks, we have the forces of the dry friction. We have assigned definite magnitude of the 0.2. It is not on the description of the assignment. Yeah, but we have to assign as well the friction factor is 0.2. 0.2 is friction factor as well. So this is a friction factor. This force action assigned 25 newtons. The two masses, 6 plus 4 is 10 kilos, have to be equal to all forces action, including with the to the total is m. Just only we can find it as we denote as m. So we can consider this balance. We have only one unknown here. We have as well the masses. Mass is equal to the acceleration of the gravity 9. Considering the mass is 10, but acceleration 9.81. We can just to cut the common factor. Common factor could be m. F divided by m. F applied 25 divided by m. Total is 10 kilonewtons. So we will have the total acceleration from this formula when we derive the total acceleration of this two blocks and action of the force, considering the friction force, dry friction, and the forces of the inertia is 0.54 meters per second. So, but the questions remains: what is the force acting between these two blocks when they move under action of the external force? And this force between two blocks on the second block, on the first block, acts from the second block, acts from left to right, S2 we say, and from on the first block it acts on behalf of the second one from right to left, we can denote these forces as action between the blocks as just the same force, because the action equal to the counteraction, the same force. And considering the balance of forces action on the block first, taking into account the frictional forces and the inertial forces, in addition to the applied one, the force of the interaction of the parts of the block is. So if we consider the balance of all forces action on this definite one block is therefore the second block in the second state, not the first block. Force number magnitude 25. The mass of the first block is 6 kilos multiplied by the acceleration and multiplied as well by this is a component of the friction force. This is friction factor multiplied by 9 and 81 gravity acceleration. So, and this balance gives us 10 Newton, the force as action on behalf of the second block to the first one when consider balance of the forces action on the first block. And what about the second block? Considering the balance of forces in the block 2, take into account the frictional forces and the inertial forces in addition to the applied ones, the forces of direction of the parts of the block is, we can consider the balance of the forces acting on this block is the force F have to be equal to the forces of the inertia and the forces of the friction. Forces of the friction the mass of the second block by the acceleration we got when we considered the motion of two blocks together and the action of the external force. So the force S we can find as well 10 kilos. This is a force which acts on behalf of the second block. This one is S2 on the first block. No. From the first block to the second one, this S2, the index 2 means that the force acts on the second block. This S1 means acts on the first block. But this is the first block, indicated one, and this is the second block. So consider the balances of the motion of each of two blocks moving separately. We can find the same force action between the blocks equal to 10 Newton. This is a consideration in the balance. This is decision of the director show. So that is the director show is finding of having the elements of the motion of the system, of the mechanical system. The assignment is to find the force. Finding the force is the director show of dynamics. We have the inverse show as well. The inverse show is having the force to find the element of the motion of the elements mechanical system. Could be just the material point or material body, etc. Questions and comments. The internal inertial reference coordinate system. The stationary and moving uniformly and rectilinearly. First, when I told a little bit about the director show of the mechanics to find the forces acting onto the mechanical body or mechanical point, and when we have the elements of the motion mechanical body or the mechanical point and the inverse a show of the mechanics, that is when we have the force or maybe moment acting on the mechanical body to find the elements of the motion mechanical body. This all we do in the stationary or moving uniformly and the rectilinear coordinate system. Coordinate system, that is system inertial, in which we have fulfilled the laws of the mechanics of Newton. This system have to be stationary or have to move uniformly and rectilinearly. Then we can consider the issues of the mechanics in this system, coordinate system. 972 finding by double time differentiation the projections of acceleration by point for specified parametric the law of motion independence on the time parameter, or for assigned vector definition of the point motion determination of projections of the axis of force vector acting on the body and the magnitude of this force. The magnitude of the force we can find the same as by the Pythagorean theorem, but for the three-dimensional space, this is square root of squared 3 sums, not 2 as for the flat state. And the double time differentiation, if we have assigned element of the motion, like the coordinates of the motion, can be this assignment can be in the vector form as a total of three vectors of the projections of the companions on the coordinate axis, Cartesian coordinate system. Then we can transform this into the parametric assignment. Actually, I do not find any big difference between the parametric assignment of the motion or the vector assignment of the motion, because the vector assignment is that of the components as well. We have in the parametric, the vector assignment is a parametric as well. So, but formally, these assignments of the motion are a little bit different. First, we would have the coordinate assignment of the location of the material point coordinates as dependencies on time. Or if we have the vector assignment, it's convenient to transform this vector assignment into the coordinate assignment. Next, to do the differentiation to find elements like velocity and the acceleration of the material point. In dynamics, we need to have the acceleration to have the forces of the inertia. The force of the inertia, in accordance with the D'Alembert concept, we can consider together with other forces acting on the mechanical body. In this case, we have to use the same laws as we have in statics for the balance, considering the forces of the inertia according to the D'Alembert concept. 973, the drawing up of equation of forces equilibrium and finding the elements of motion of mechanical system and the influence of these forces, and to find the forces acting between the elements of the system using the condition of balance of projection of forces acting on the element of mechanical system, both the friction force inertial ones as well as the applied forces. This is important only in this definite one comment that on the action of the when the body moves, not only the inertial forces arises, but as well the forces of the resistance. It could be dry resistance, could be rolling resistance, etc. So forces of the resistance we have to consider as well, because in the static state, we do not have the forces of resistance, the same as we do not have the forces of the inertia. So to be more exact and to be honest, to use the D'Alembert concept and to decide the direct or inverse issue of dynamics to find the forces having the elements of the motion of the mechanical system, and when we have to find the element of the motion having the external forces in the balance equations in accordance with the D'Alembert concept, to be honest, to be accurate, we have to account not only the forces of inertia and maybe moments of inertia, it's moments of the moving of the inertial mechanical elements of the systems, but as well we have to consider the forces of movement, that is the efforts of the friction to the motion. It could be friction, dry friction in usual mechanics. It could be friction of the rolling friction. It could be the friction others, like in hydromechanics, we have the resistance of the liquid like a water or air to the motion of the mechanical body. Thank you.